Hello, welcome to this video. We're going to go over a question or a couple questions dealing with Pythagorean theorem. Specifically, we're going to look at Pythagorean triples, and we're going to see, is there a set of numbers or a group of numbers that would in fact work as a Pythagorean triple? Okay, and how do we know? How do we solve for it? So here's the question. The question is it possible for a right triangle to have sides that measure 15, 20, and 25? Okay, those three numbers. We're going to look at a few examples, okay, specifically this one right now. So first thing we're going to do, we're going to draw out this triangle here. We have a right angle triangle. I'm not too worried about the size of the triangle right now, as long as that we can label them. So we're going to take our 15, 20, and 25. 15 and 20 being our legs of our triangle. And sorry, there's no right angle in there, but we can understand that there should be. And so we're going to label them as 15, 20, and then 25 being the hypotenuse due to the fact that it is the longest side. All right, now, could we use Pythagorean theorem to check and see is this in fact true? Yes, we can. A squared plus b squared equals c squared means that our two legs squared have to equal to the hypotenuse squared if we add up the two legs. So let's go through and try it here. 15 squared plus 20 squared is equal to 25 squared. Is it? Maybe, hopefully, let's check. 15 squared is 225, 20 squared is 400, and 25 squared is 625. Does that all still work? Yeah, it does, because if we add 225 and 400 together, that adds to 625. And so these three are in fact a right triangle, or they would work as the sides of a right triangle. We call these a Pythagorean triple. So you can use Pythagorean theorem to see, do we have a Pythagorean triple? Pythagorean triple being three whole numbers, which we can use to make a right-angled triangle. Let's try another pair. What about 10, 25, and 27? All right, so here's another pair. So again, let's take our triangle. Now I modified it a little bit to make it a little more accurate scale-wise, but I plugged the numbers in just the same. 10 and 25 being the two legs because they are the shorter two, and 27 being the hypotenuse because it is the longer one. Let's do the same thing now. A squared plus b squared equals c squared. We can plug in our numbers. Our two legs are a and b, and then our hypotenuse is c. 10 squared plus 25 squared is going to actually give us 725. 27 squared is 729, which are very, very close, which means we can just allow it to slide, right? No, okay? These don't work, okay? It's close. It is very, very close, but these, in fact, don't work for a Pythagorean triple, and they are not possible for a right-angled triangle. All right, so now we've seen one that works, one that doesn't work. Let's try a third one. Gladly pause the video here if you want to and see, does this work? I'm going to go over the answer right away. 9, 40, and 41. Are they a Pythagorean triple? Or could they be made as a right angle triangle, is another way of saying that. So let's draw it out again. 9, 40, and 41. 41 is our hypotenuse. 9 and 40 are the two legs. So we're going to plug them again into our equation. 9 squared and 40 squared are given there. If we add them together, we get 1681, and that is exactly the same as 41 squared, and therefore it is in fact a Pythagorean triple as well. Thank you for following along. I hope this has helped you. I hope it gives you an idea as to what a Pythagorean triple is.